Hey students, this is lesson 1.2b, slope and scale. In this lesson, we're going to learn that changing the scale of a graph can affect the appearance of the graph. So you're going to learn how to make a graph look steeper or flatter just by changing the scales. But before we do that, watch this little video that shows why math is important. So there you go, students. Yeah, to accomplish that, you would need quite a bit of math. I wouldn't recommend that. The kind of math they use is actually quadratics, which is something we'll be learning later in the year. But you might want to pay attention to the math we do so that later on in the year you can understand quadratics better. Not so that you can do that at home, but just so that in general you're a better math student. But right now we're going to talk about slope and scale, and we're going to start by, I just want to quickly show you what effect you can do by doing these two graphs here. We're going to graph this equation y equals 2x plus 1 on each grid, and you're going to notice the difference it makes. So notice this grid, x goes up by 1 and y goes up by 1. They both have the same scale. In this grid, x goes up by 1, y goes up by 2. So I'm just going to graph these points, x, y, and using this equation, y equals 2x plus 1. So I'm going to multiply x by 2 and then add 1. 2 times 0 plus 1 is 1. 2 times 1 plus 1 is 3. 2 times 2 plus 1 is 5. And so on. We can see the pattern is it's going up by 2 every time. Now when I graph them on the first graph, I graph the point 0, 1, 1, 3, 2, 5, 3, 7, and so on. We get what appears to be a really steep graph with a slope of 2. When I graph those same points on the second one, 0, 1, 1, 3, 2, 5, and so on, I get a flatter graph. And what caused that was the fact that this scale is 2 on the y-axis and the other scale is 1. So that's kind of the idea that we're going to use. We're going to mess with the scale so we can either make it look flatter or make it look steeper depending on what we want to accomplish. Okay? So here's the first problem that I'm going to do with you. It says Ava's mother thinks Ava is spending too much money on DVDs. Ava says that since DVDs cost only $10 at deep discount sounds, the amount she spends does not increase very quickly. Ava decides to make a graph showing how the total money spent changes as she buys. And she thinks if she chooses her scales carefully, she will convince her mother that the amount increases at a slow rate. So we're going to draw a graph that Ava could use to convince her mother. So what we want to do is draw a graph that really appears like it's fairly flat, like it doesn't have much slope to it. So in this case, I'm just going to let my x-axis go up by 1. So this means the number of DVDs just goes up by 1. And then on the other axis, it's going to be the cost of those DVDs. And we know that that goes up by 10. So, but I don't want this to show that it's going up very fast. So I want to think about it. What if I had, well, we know that we'd have a point at 0, 0, because 0 DVDs cost 0. This is a direct variation. But if you buy 10 DVDs, that'd be $100. What if I had my $100 right there? So I'm going to choose a scale that'll allow me to get to 100 quicker. And that scale would be 20. But I'll keep this going to kind of give the effect that that the line's fairly flat, which means she's really not spending money all that quickly. So 1 DVD is 10, 2 is 20, 3 is 30, and so on. And so here's the dots I get. Now these I wouldn't connect because you can't buy like half a DVD. So I would just draw it like that. But then I would say, you know, if I was Ava, I would say, hey Mom, look at this. It's not going up that fast. It's a pretty flat line, you know. I'm not spending that much. Well, Ava's mother knows a little bit about graphic too, because she had Mr. Hermanson for a math teacher who taught her this. And what she's going to do is make a graph to convince Ava that her total cost is increasing rather quickly. Okay. Now there's a couple ways we could do this. We could change the variables. If we wanted to leave the DVD numbers the same, we could do that. But what I'm thinking that Ava's mom would do is maybe have it start at 0, 0 like this, and maybe have it go up, increase really rapidly. So like if we had, if I instead put the 100 up here, which means I'm going up by tens, 90, 80, 70, like this. Now to get that to happen, we know that she has to buy 10 DVDs to cost $100, right? So what I need is for my 10 to be right here. Well, to get that, I only have 5 spaces to get that 10, so what I need to do is just go up by 2s instead of going up by 1s. So this is 12, 14, 16, 18, and 20. And now, 1 DVD that costs $10 is right in here. 2 is 20, 3 is 30, 4 is 40, 5 is 50, and so on. And notice that this line, and again, I'm not going to connect the dots because you can't buy half a DVD, but notice how that line kind of makes it look like she's spending a lot of money because it's so darn steep. All right, so that's the idea with this lesson. If you want to rewatch the video, whatever, so that you can understand it a little better, go ahead and do that. But if you want to try a problem on your own, do that. Other than that, I'll talk to you next time we meet in class. Good luck with this.